Sounds like the PA system's turned off. I don't know. Did I press something? HDMI. Oh, you know what? As soon as let's see. Main. I'm going to ask Janie to do a sound check on the live stream. Is that a reasonable idea?
Yeah.
Great. Janie, can you log into the live stream and do a sound check? Just make sure you can hear me. Yeah, you just go there and just pull it up, and you should be able to hear me. Thank you. Oh, you need flash? Oh, good.
Here, this is your preview.
Very good.
I'll talk with Janie to make sure that it's good.
Super. I wonder why the PA system turned off. This light's still on, right? Is that? You know what? This light just turned off. Is that?
Did you switch your... You're right.
Is that what it would? Thanks. Thanks, Robin. Can we just swap out the battery, or should I?
No, this one's good.
Oh, cool. Can I just disconnect the microphone and plug it in?
Let me just get back.
Here. There we go. Thank you. Hello? Good. Good. Great. Sounds just like it's on. Thank you, Janie. Thanks, Robin. Cool. Thanks for coming, everybody. And I hope you can hear me. Thanks for coming for a second time. I want to start today by getting everyone on the same page with Git and GitHub and a few last-minute SBT requirements. I ran into an interesting SBT fluke today because the type-safe repository for Maven artifacts went down, and my local SBT configuration had some alternative resolvers, but Travis did not, so I spent a lot of time fiddling with that. Resolvers are stored in like 3 different locations, and I want to thank Alec for figuring out with me what the solution was. But we're going to, since you guys are going to have to download those artifacts, we need to implement that solution too. So I want to encourage everybody to fork this repository, because I am updating this Scala class repository, and the easiest way to get my changes into your own copy here is with a fork. So let me show you an example. These people have forked the repository. Who's done this before with GitHub? Forked a repository. Okay, great, cool, great. Okay, of course you're also free to clone the repository as we did 1 week ago and just do a git merge every week. I think that the GitHub merge in their own UI is a little bit easier to use. So if you don't feel that comfortable with Git, the easiest way to do this is with GitHub. The tutorials will definitely build on the prior ones, so you don't want to start out with a fresh copy, like a fresh zip file every week. A lot of people last week went over here and just downloaded the zip, and that is going to have shortcomings very soon. So while you guys choose to fork that repository or not, it's up to you. We need to show a fix here, because otherwise SBT is not going to work today, because that type-safe repo is down. I know they've renamed themselves type level, but the repo is still called type-safe. Not type level, Lightbind. Everybody needs to enter, if you're on Mac or Linux, this hidden folder, .sbt. I don't have a solution right off the top of my head for Windows, so I got to follow up with you if you're using Windows. I'll follow up soon. Please go into .sbt. It's a hidden folder in your home folder. Then please go into the 0.13 folder. If there's not a folder in here called plugins, you need to make one with make-dir plugins. Sorry, blow this up in size. And you should have a file in here, or make one, plugins.sbt. Blow this up large. We are fixing SBT. I'll walk around and make sure it's going smoothly. Not in the tutorial folder. This is in your root, your home folder. So let me pull this up 1 second. Is everybody on Gitter? If you're on Gitter, please let me know. Anyone who's not on Gitter, please visit this link. So if I have some little snippet of text or something to send you, I'll probably put it on Gitter. That is correct, yeah, because you are adding a sequence to the resolvers, not just a single element. Thanks for asking. That is... Exactly, yeah. So what you have to do is you have to, because the default SBT repository isn't working today, we're going to have to configure some alternatives. So I need to help everybody with this, otherwise nothing's going to work today. Cool, great. Let's see, so plugins.sbt. The folder is plugins, but the file is plugins.sbt. Yeah. Hey there. .sbt. Sorry, change directory. .cd. .sbt. .sbt. The dot means hidden. Now do an ls to print what's in the directory. Great. Now go into 0.13. And then make a folder. Copy that hierarchy there. It's a folder called plugins and a file called plugins.sbt. Let me turn off this light.
Is everything that you posted on the getter message, all of that?
All of that goes into plugins.sbt. Yeah, thanks. Sorry, yeah?
So I have the file plugins SBT.
Good.
I don't know how to open it from here.
Oh, okay. You could use Nano, that's a text editor, or you could, it's going to be hard to find it in the Finder because it's a hidden file. In fact, to do edit, I think, or open, actually open, just do open. And I think the Mac will open the file. You misspelled plugins.
And then I get this guy.
So it looks like you created a folder accidentally, so you need to do an rmdir, rmdir. Delete that m, sorry for remove, rmdir. Delete, yeah, you have two D's in there. Great. Okay, delete plugins.sbt. No, sorry, no delete, it's just. So now do open plugins.sbt. Okay, just do open. Dot. Great. Now, there's a way to do this with touch, except I forget. Yeah?
I will only have one staging file inside the.
That's okay. You have to create a folder called .plugin. Not .plugins, just plugins. So you do makedir, mkdir. Because when you pull the latest changes to Scala class and compile, simply loading SBT relies on this because it's pulling some artifacts for SBT. Some of you might have gone on the way without doing this if you had an Ivy cache already. So some of you would be okay from the previous week, but I figured we should get everyone on the same page here. We don't want to rely on the Ivy cache. Let's see. Oh, here. What's your name? Sean. Try this. Oh, good. Good. You did it with Nano, except I figured it would be difficult to paste into Nano, but it sounds like you've... it's okay.
Not sure.
And it always does this. It's like.
Right, and then it doesn't open, but it is there. Is that not what's supposed to
Ooh,
happen?
so do you have the Finder window still? Because a minute ago you had a Finder window there. Good. Now, yeah, you can't... You have to do open dot to open up the Finder in that directory. Yeah, great. Now you should see plugins.sbt and open that up with, not the terminal, but a text editor or something. Yeah.
Got him.
Great. Okay. That's good. Indentation doesn't matter. Yeah, super. Okay. So everyone should end up with something in their plugins.sbt. Not this exactly. This is what's in mine. The one that I put on Gitter is an improvement on this. From Gitter? Yeah, that's fine. Yeah, yeah. So now let's pull the latest changes from Scala class, and we will see if SBT works. So please do not just download the zip. Please either fork this, and whether you fork it or don't fork it, you're going to copy this link here. We'll go to the terminal. And we'll do git clone and paste the link. I would encourage you to fork it, though, before. And then once you fork it, this address is going to be your name / Scala class. Let me just do the next step, and then I'll come around and see where everyone is. You will have a Scala class here. Do SBT. Hopefully that part works. Say again?
Is it SVT? Then go make some coffee.
Yeah. Yeah. Knock, knock. Knock, knock. It's a joke. It's a
What? Is there?
Java. Okay. That's good. That's good. You get it, plugins.sbt, then you're going to copy that. That's plugins.sbt has to go inside of a folder plugins. So you're just one level too high up. So kill get it there. Okay, then make dir. Sorry, mkdir. Good. Yeah, mkdir. Oh, you've made a folder called plugins.sbt. Okay, I got it. So just do a rename. I think that's mv for move. Move plugins.sbt to plugins. Great, and then enter. Now do ls, ls, then go into plugins. Great, and then ls, and do cat plugins. Good, good. That's what we want. Yeah, thanks. Okay.
I do have one question. I cloned the repository last week, so
Okay.
should I just clone the one that I just forked, or?
Let's see. Yeah, clone the one that you just forked, and because the SBT tutorial is kind of independent from every exercise going forward, it'll be easier to merge that into this than vice versa. Okay. So, yeah. Yeah.
So I had an error when I ran SBT.
Okay. That's a good example because that's what. In fact, could you? You don't have to copy it. This is the problem I'm trying to prevent. So we need to set up SBT correctly. So show me what your plugins.sbt was.
Sure.
Yeah. The other thing is it looks like you never left the folder. You don't want to bring this whole project into that SBT folder. You want to put it somewhere else. But we can fix that later.
Sure.
Okay. Great. Okay, you're in plugins. Now show me. Okay. Okay. Okay, you can quit this. Great. Now, delete that copy of the repository. I'm not sure where it is. Is it right there?
It's just on the example.
Yeah, just delete example entirely. Great. Now go to your home folder. Okay. Now clone the project in there. Good. Okay, now enter that. Now the SBT out, see if the error happens again. Same problem. Okay. Show me your plugins.sbt again, please. Can you show me the folder that this is in? I think if there's some minor difference, like it's in the wrong folder. Okay, .sbt, and the file is called plugins.sbt. Okay, let me put this up on the screen one more time, and let's make sure it's identical. Hey, give me 1 minute. Hey, Harry.
When you run programs, it's just going to
There's a couple of levels of this, and what you just edited there are like dependencies of SBT itself, compiler plugins, maybe not compiler plugins, but plugins to SBT itself, not Scala artifacts that you use later, like cats or Scala test or things like that. So you have these copies of resolvers in multiple places. And as a general rule, you want to put as many of those resolvers into the project like Scala class as you can, because then it's easier to go send a copy of Scala class around without somebody having to configure this hidden .sbt folder.
Did you say Scala class now like you did front end and back end?
Yeah. So it's, I mean, for general, like you want the class to be, you want your repository to be entirely self-contained. And this problem that I encountered today is a violation of that, because it's not able, you guys can't get running with it just by having a copy of the repository and any version of SBT installed. The ideal is to have any version of SBT installed, fire up the repository, and SBT will download the most recent version of SBT that it needs and every other artifact needed by the project. So what we've encountered today is a violation of that. So it is not the library dependencies. Library dependencies are artifacts used by your Scala code, like cats or Scala test or the Breeze library. Good question, yeah. So there are different types of dependencies. John, sorry I can't help you much right now. Let me just paste this into the lobby here, and if you can spot some difference between your plugins file and mine, or not mine because that's not the one you're copying. Let me give you a copy of mine, and perhaps that one will work for you. Don't want that one, don't want that one. A copy of mine with some redactions. Curtis, were you able to build the repository in Windows? Because I don't have the same trick for Windows. Okay, so hopefully everyone's on the same page here now. If you type in projects in SBT, you're going to see all these. Lab answer, MISC answer, tutorial answer, those are empty folders. And the reason for that is that my build configuration is identical in the private repository and the public repository. I'm trying to avoid the spread as much as possible. It's just that the source code is missing. So if you're interested in how that works, it's because SBT will it will create folders for any project, whether there's code in there or not, so long as it's defined in the build configuration. All you need for today is to go into Project, Tutorial, and then make sure it compiles as it is. If you go back to GitHub, that's the only way you can do it. Yeah, thanks. Because, and I'll make a comment about that. I'm not sure if you can do this in Maven. You might be able to. If I were to navigate in my terminal, go into tutorials. I think this will answer your question. And then start SBT in here. I think if it were Maven, I would have a POM file in here. I would have a POM file for that module or sub-project. In SBT, there's only one place where you can start SBT, and it's in the root of the entire project where the build.sbt is. So last time somebody had a bad problem. They couldn't figure out why SBT wasn't picking up their build configuration. And a perfectly reasonable problem. It's a good question. The problem was that they had started SBT in some folder like distributions or plotting, because they intuitively thought that it would start SBT in that sub-project, but that's not how it works. You have to start SBT in the same folder that this, where did we go? That this file is, yeah. Thanks. A history?
Yeah, like you have in the command prompt, we have a history, look at all our commands, SBT, have that going.
Absolutely, yeah. So let me show you. Sometimes it gets blurred together with the history of the command line. So I guess to answer your question, it's not a separate history from the history of the command line. Yeah. Command clear in SBT? There's no built-in SBT command for like erasing the terminal. There's a command clear in the Unix terminal, which erases all the text from the terminal. There's a different command called clean in SBT. Is that the one you're referring to? Yeah. In clean. Yeah. What clean does is I'll show you. Let's go into tutorial. Okay, I made a brief mention last time that compiled Java or Scala code or any other JVM language goes into a target folder. It's supposed to source. And clean will erase that target folder. So most of the time you don't have to use clean, but in Maven and SBT you occasionally have some really weird problem where you have to delete, the pre-compiled Java or Scala code. So that's what clean is for. Yeah, but just a compile command will replace any previously compiled code that it needs to. So, yeah. It's most of the time, with a few exceptions. But okay, please open up this README here. I'm going to go to tutorial. I'll put a link to this in Gitter. I'm going to talk a little bit about this tutorial for a few minutes, just broad strokes, and then I'm kind of going to look over your guys' shoulders and help you work through it. So these Lambda LA sessions are shifting away from being lectures and monologues and into more hand-holding help through the exercises. So. Okay, so in this tutorial we're going to touch on all these topics. Most importantly probably are type classes. The chapters you read in the book talked about recursive data structures, so I have a section in here, totally applied example of using a library called JSON4S to read a JSON file and parse it into Scala objects. So that is what you would call JSON deserialization. Serialization would be going from Java objects or Scala objects to JSON text like this. And deserialization is moving that into some sort of data structure. And it's a great example of a recursive data structure. These are the JSON 4S types. Please look at this library, JSON 4S. These types capture just about anything that can be stored in JSON, and it's recursive. So just like JSON is recursive, let's look at the JSON. Here we have what's that called? JObject. Which starts with these parens here. It's kind of a collection of things. You have a thing here, a thing here. Let's see. Oh, this is the grammar. Sorry. Here's the JObject. I get to store lots of different fields and values in here. Key value pairs. And it's recursive. So in here I have another JObject inside its parent JObject. So JSON 4S JSON is a great example of a recursive data structure. And when you parse JSON into Java or Scala so that you can use it in your code, you'll end up with a recursive data structure. JSON has key value pairs like this, name, this is the key, the value is Bert, and it has arrays. So I can have an array of other JObjects. All those different things are captured in these types that are provided by JSON 4S. Let's look at JObject. JField. JField is a key value pair. So let's go up here, find a couple of JFields. This is a JField. This is a JField. This is a JField. What do you guys think is the value in this JField? If it's a key value pair. I'll show you the type of JField again. Here's JField. Let me put a link to this in Gitter. All right, let's look at this example. JField, right? This is the key. This is the value. This is the key. This is the value. This is also a JField. So what's the key in this JField? What's the value? Right. So we see how it's a recursive data structure. And let's look at what JValue is. Here's JField. So the value is this thing on the right. Here it is. Let's follow that back up to the top. This is defined up here. And that's how you can end up with any of these things in the value of a key value pair. But don't take my word for it. I want you to parse some JSON and produce the data structure. So let's see here. So please go into console. Should be an SBT here. And you should be in tutorial, project, tutorial. And then enter the console. Import org.json4s. Import org.json4s. Native JSON methods. So let me make sure that everybody can do this. How you guys doing? Cool. Okay. Okay.
I was looking how to do the Scala console inside SBT. I didn't know that. I was looking.
Oh yeah. And what's nice about that is that you get all the things, all the dependencies that are provided by the build configuration.
Oh, really?
Yeah, so that's why you have access to JSON4s. If you were to just fire up Scala anywhere, you wouldn't have all those things. Yeah, thanks. Hey. Okay, let's see here. Why don't you go up higher. Go up here, yeah. Go higher, sorry. Higher. Okay. That's the same issue. So can you show me your plugins.sbt?
Yes.
.sbt, yeah, great. Cat, yeah, that's fine. Plugins.sbt, great. Okay. Okay, let's try this instead. Go open up a folder. Yes, please. Show me the root of Scala class. Not in the browser, but in your file browser. Yeah, great. Great. Git repo, Scala class. Great. Go in there. Go into project. We're going to disable something and see if this fixes it. So open that up. Great. And then comment out all of those.
All of this?
Yep, this is forward slash, yeah. Keep going. And then save that file and close SBT and start it again and let me know. Hang on a second, John, I got one more idea for you.
Oh, I think I got it.
You got it working?
Yeah,
Great.
That code helped.
The most recent code on Gitter? Okay. Okay, good.
So I think I might have missed a step. How did you get to Scala?
Oh, console, into the console. The C-O-N. Oh, no, sorry. It's console within.
Oh,
Yeah, exactly.
So you have to do it when you're within SBT?
Exactly, and the reason for that is that.
Start Scala and
No, that's fine. The reason for that is that when you start the console inside SBT, you get all the dependencies that are provided. Yeah, that's what you want. So, hey, Curtis.
So here's on this one. Let me go back. I actually had a console terminal running. So and Scala. I mean, and here there's my project, which is right here. I wanted to show you just a minute because I just had it open. Yeah, and so as you can see, they go down here. Here's the example that I created in Scala, and then I created this build here, and then as I ran the build, so here's the success. I compile it,
Okay.
and then it says there's the output after I ran it. Hello world, on the hello world _ object Scala class. So, and then if you go back to here, example 2, there it is. So
Gotcha.
I'm actually running it in chain, and then here's the terminal here. And then there's an.
Let's see. We gotta
go
work
back.
inside. We're not starting our own project from scratch. So have you forked the Scala class repository in GitHub?
No, yeah. I kind of like.
You wanted to do it from scratch?
Yeah, I kind of got it. I kind of got it into this mode right here. So, but I will, as I'm recording as well as listening to you.
Gotcha.
I will regress and get back to you and say,
Okay.
oh, yeah.
Okay.
Because I feel now that I got this far in this.
Yeah.
You know how many where you get to the point where I'm beginning to understand certain commands, and I'm not just like caught in the terminal anymore. I understand what's.
Well, it's up to you. I mean, you might.
Yeah,
it,
but
it takes.
I'll get back at you.
Okay.
It's just like I see it, but yet I gotta like step back.
Sure.
Yeah.
Yeah, you got it.
It's this is like.
Thanks. Hey, Harry. How's it going?
Doing stuff when I type console. I don't know if I'm.
That's good. No, that's exactly right. So there's a bunch of dependencies that aren't cached yet. So, well, we were talking about doing this stuff on a plane with no internet connection last week, right? I wasn't expecting the repository to go down. So, yeah. No, you gotta. You can't like preemptively download dependencies. You have to have a project that
has
those dependencies.
right.
Yeah.
If the file
Sorry.
when I ran this one, can I ask you this here?
Yep.
When I ran this build right here, this SPT build,
Yep.
and I went from this library dependency plus equals org Scala test, and I
Okay.
did that test,
Okay.
that pulled that down then, but today is
Yes. Well, when you not just by writing that, but by actually firing up SPT, that would pull it into your IV cache.
Oh, okay.
Yeah.
so it's in the cache now from here on out until I
For that particular version, it's very, very finely, very, very carefully specified version. So one number off and it's no longer cached. Yeah.
okay.
Yeah.
So and I'll listen to what you say.
Sounds good.
Thank you. I'm
Yeah.
beginning to see it was about getting clearer, but it had it took like 4 to 5 hours just straight
Cool. Well, I hope the README
Doing
is useful
homework.
because I.
doing homework.
Cool. How's it going?
I think pretty good. Based on the type of years.
Okay, so that's a problem. Yeah, for some reason it's not parsing it correctly and it's producing a J nothing. So, how's it going?
Stupid question. So when I run SBT in this directory,
Yep.
I end up getting these like the errors that it can't import. But when I run it in, so I did it in Scala class, it works.
That's because you've fallen for a common trick,
Okay.
which is that you're not supposed to start SBT in a subdirectory of the project. You have to start SBT in only the folder that contains build.sbt. And what's so tricky about it is that SBT will start as though it's working correctly, and you won't find out until later, like just now, that you don't have the right build configuration. So you don't have access to any of the things in that build
So
configuration.
each project only has one build configuration? Like in this repository, there's only one build? I thought that there were...
Well, you can split up a build configuration for the sake of, modularizing it. Like I might have a file that contains common settings, another one that contains, dependencies or something like that. But basically, to answer your question, yeah, there's only one build configuration. It's not like Maven where there's a POM file in every module.
But in this repository, the root has a build.sbt, and like say using Breeze root last week also has a build.sbt. So I could fire up SBT in either one of those directories. Or is this just...
Wait, the root? Oh, well, the SBT tutorial is totally a separate project.
Oh,
Yeah,
okay.
yeah. So, yeah.
Cool, thank you.
Yeah, thank you. Let me just point out one more thing is that last week when we looked at the SBT tutorial in here and we had all these different build.sbts, that's an aberration from how this class is going to go normally. Most of the time, 95% of the time, we're going to be using this one single build.sbt that contains all the exercises. Yeah. You should also try parsing some JSON that's longer. So let's see if this works. Let me store that string somewhere. Okay, so at this point, you've probably only imported org.json4s and this other one here. And now I want you to import this object here. Oh, you can't do that because there is an app here. Let's see. Bum, 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 bum. You cannot import from an object that extends an app. So what you should do here, open up hierarchy.scala in the tutorial and comment out extends app. You'll need to quit the Scala interpreter so that you can recompile the Scala code that you've just edited. I'm going to go into console. That's okay. Import. One second. Okay, so please make that tweak to the hierarchy file. This is a runnable example, but we want to do it on the console. You cannot really use it if it extends an app because it's going to try and start as soon as you use the object. Then you need to quit the console. You just do, what's the command? Exit. Colon quit. Yes. Well, you're making it accessible as an object rather than as like a runnable application. Yeah, so. Okay, so once you've done that, you have access to this com.datascience.education.tutorial.lecture1.hierarchy._. Oops. You want to make that import statement. And then there's a value in there called JSON1. You can enter that in the console. And this is a larger piece of JSON to parse, just for fun. Let's see if it works. There. Better example of a recursive data structure. Yeah.
I don't know why it's doing this still. Why? What is the point?
Oh, there's so much stuff. There's so much stuff.
Like,
That's why.
what does Twitter stuff have to do with anything I'm doing?
It's dependencies of dependencies. So
So I should just expect this to take forever?
yeah, basically. Thanks for asking. Yeah, it's not broken. Did you hear the knock knock joke? Knock knock.
Who's there?
Java. Hey, okay.
This import's correct? DataScience.
Okay. That is not correct syntax because lecture 1 is not something that can be imported. But you have a different problem here.
Yeah.
So,
So I just had to find out.
okay, open up the hierarchy file, please. Hierarchy, yeah. Oh, good. Okay, and you should be able to access that object there. Did you compile?
Maybe that's fine.
Yeah. Okay. So quit the console again.
Okay.
Okay. So after you
Okay, so starting to
SBT. Yeah. Great.
and then typing the file.
Go into the tutorial. That's the problem. You started the console in the wrong sub-project, so you don't have access to the tutorial code there.
Thank you.
I'll make note of that for everybody. One other mistake, good to note, is that what the console has access to is determined by what sub-project you're in. So if you open up the root subproject or any other subproject, you're not going to have access to this tutorial code unless the subproject you're in depends on the tutorial subproject. I'll show you right now. Here's how you exit the console. It's with :quit. I am in the tutorial subproject. I'm going to do console. Like that. Hey.
Still having issues with the main protocol? Oh, it's working? Oh, okay.
Great. By the way, to anyone watching the live stream, please ask questions on Gitter, and I'll notice them.
Once I import hierarchy, what am I supposed to do with it?
Okay, once you import hierarchy, you'll have access. Let me go back up here. Here's the import statement. There's an object in there called JSON1. It's a big string. So then you want to use JSON4S to parse that into JSON4S classes. Yes. Yeah.
Is that considered good practice?
Yeah. That's fine. Yeah.
So if I imported something else and it had the same variable name or the value name, how does Scala deal with like namespace conflict? Like if there was another JSON one and another.
Oh, well, I think the most recent import would override.
Okay.
And you're going to get into a more complicated version of that question with this type linearization section of this tutorial. So it's an important topic. Yeah. You're welcome. Hey. Say again?
When we do parse, does that put it into the Scala object?
It is, yeah, it is, and I'll show you. So what you've done with parse, does this have Scala doc? I don't think so. It's lacking Scala doc. This is JSON4S here. When you use the parse method, you are producing one of these, but you don't know exactly which type it is. So you know it's going to be a J value, but you don't know what type. And J nothing is a catch-all if you parse something that cannot be parsed. So it's one form of error catching. You guys have probably seen the option and either. And if parse were to return an option, it might return a none or a sum. It would return a none or a sum. This isn't that distant from that. The none is a J nothing, so it's still producing a J value. It could be this one or any of these, and inside of those it could be other J values. So that is a nested data structure, recursive data structure. This is a great example, I think, of some of the things in the early parts of the essential Scala book.
If you knew the type of the entire JSON file, would you still have to parse it to be a JType, or could you explicitly say what type?
Okay, that's a great question. And you're saying if I know I am producing a J int, let's say a J field with a single key and a single value, which is a J int. That would be anti-pattern with JSON4S in particular. What you would want to do is probably you parse it to a J value and then do some pattern matching on it down the line. You can certainly do things like, you know, once you've produced a J value, you can pattern match on it, and if it's what you want, if it's your J int, which is what you want, you do a sum of J int, otherwise a none. But no, I wouldn't replace the parse method. Let's talk about part 2, covariance and contravariance. Before we talk about that, we have to talk about subtyping and supertyping. This syntax means that T prime is a subtype of T. So these are for two imaginary types. And later you'll see an example of those. Oh, here, I'll show you an example right now. Okay. Any of these is a subtype of J value. These are all child types. J nothing is a subtype of J value. J decimal is a subtype of J value. And in fact, J value is a subtype of J value. You're going to see an example of this later with the heirloom part of this tutorial. It's kind of a trick. So subtyping is inclusive, like that. Aside from subtyping and supertyping, there's something very important here called covariance and contravariance. Given this relationship, if you assume this much, you have these three possibilities. This is default. This is called invariant. So if I have a functor C, given invariance, there's no subtype or supertype relationship between C of T and C of T prime. So even though you could say, well, C prime is a child of, T prime is a child of T, you cannot draw the same conclusion about, or in either direction, of C of T and C of T prime. You cannot say C of T is a supertype of C of T prime, and you cannot say that C of T is a subtype of C of T prime. With covariance and contravariance, you do get that relationship. So if in the definition of the functor C, you use this plus or minus syntax, you get one of these relationships, assuming that there's a relationship between these other two types. And that's the abstract look at it. I'm going to show you a couple of concrete looks at it. Why would you want to draw a relationship between C of T and C of T prime? Well, there's actually very good reasons. Let's look at the definition of function 1. It's very important. Function 1 has two types, not just one. So it's kind of like we were talking about T and T prime before, and we've got to talk about T and R. The input to the function is contravariant, and the output is covariant. And what this enables is a relationship between two different functions. If I expect a function from cat to animal, I can safely substitute a function from cat to cat. That is because cat is a subtype of animal. Let's go back up here. Okay, so cat is over here and animal's over here. And given contravariance, which is this one, that means, let's see, okay, this is cat and animal. That means that function outputting animal is a subtype of function outputting cat. Sorry? Components? Well, let's see. This should be reordered with the let me take a step back and not talk about function because it has two types in it. So let's just talk about one that has one type. Imaginary type called output channel. Okay, so this is a class and it's used for writing something somewhere out. The type that it outputs is A here. And let's assume for the sake of argument that int is a subtype of double. Because let's say, aside from floating point precision, you can express any int in a double, but not vice versa. So we want this relationship that int is a subtype of double. We want a relationship that an output channel of ints can substitute for an output channel, let's see, of doubles, if it's backwards. That should be a plus. Just kind of analogous to the output type of function 1. Sorry. I'm going to skip ahead to part 4 because I think it'll make part 2 make much more sense. Why could we substitute a int for a double, assuming int is a subtype of double? It's because this thing called the Liskov substitution principle permeates object-oriented programming. It's all over the place. Here's the assumption. If S is a subtype of T, then objects of type T may be replaced with objects of type S. So if I have int as a subtype of double, anywhere I expect a double, I should be able to substitute an int. Let's look at a couple of subtype relationships here. We have a bunch of classes, and each is a subtype of the other. Grandparent is a subtype of great-grandparent. Parent is a subtype of grandparent. And child is a subtype of parent. We have a case class here called heirloom transition. I have two generic types inside that case class. A stands for ancestor, and D stands for descendant. So what I want to do here is only allow an instance of this case class to be constructed if the descendant is actually a subtype of the ancestor. It's kind of made up. It's like an heirloom going from a grandparent to a grandchild, something like that. If I put in a grandparent into ancestor, and a child into descendant, that will compile. That much is correct. But what I want everyone to do is the opposite of that, which is putting the child into the place of the grandparent and the grandparent into the place of the child. And you're going to see that it compiles. And the challenge is to explain why, because it's kind of counterintuitive. Hey.
I was going to say why I think it works.
Give me a few minutes.
Okay, yeah.
This is in the heirloom file. Hey, Carl. Sorry?
You saying Scala that the grandparent can be derived from the child?
Yes. Yeah. It's the counterintuitive part of the Liskov substitution principle. Yeah. So yeah, you're onto it. So just think, try and work through the example, and I think you've answered the question though. How's it going?
Not bad.
Cool.
I'm with you.
Cool.
I'm thinking.
All right.
Are we supposed to code it from scratch or just load the...
No, you don't have to code it from scratch. Everything's ready to go, ready to compile. All you want to do is replicate this part in the terminal, in the console. And you'll see that this one's the intuitive one, and the child is the subtype of the grandparent, right? The one that's not so intuitive is the reverse of that under task 4A here. You're going to create a new heirloom transition from child to grandparent. And the task is to explain, oh, let me bring up the file. Let's open up, not hierarchy, but heirloom. And I'll give you guys another hint, which is that there's a method in the SBT terminal, the console. Remember, I could type in a value here, and you can tell the type of something with :T. Very useful. So if you want to see the type of grandparent to child, or child to grandparent, you could do it with :T. How you doing, Harry?
I'm not sure how to import this thing.
Gotcha. Okay, let's see. Okay, are you in the tutorial subproject?
Yeah.
Great.
So I can import JSON and all that stuff, but not this one.
Good. Okay, that's fine. Let's open up. Can you show me this file in your text editor?
So this is the tutorial directories, and I think that path doesn't actually exist. Yeah, no, it does. So if I go to is it main?
Super. So you have to import it by package, not by file. You see. So you copy this, not package, but copy from com all the way to lecture. Great. We do import. And you're not quite done yet, so don't type enter to dot. I have to add one more thing, which is the object that these things are held in, and it's called object heirloom.
So just heirloom though?
Yep, heirloom and then dot underscore. And what that does is it brings everything inside that object into the immediate scope.
I see.
Yeah. So now if you type in, see like reference a value in here, reference grandparent to child, if you type that in there, you'll be able to see it in the console.
Okay. And I guess here, that's just the name of it?
That is a package. So these big projects are heavily reliant on like lots and lots of hierarchy, and that's why there's so many, this package is so long and there's so many nested folders. There's just way too much stuff. That's why so many layers of hierarchy are necessary.
Okay. So then if I do any of these, if I try to do this, I guess it should work.
Yep. Yeah, you have access to everything that's in that object.
So does it know like where these live? Like what if there's what if I import something that has two of these guys?
Well, you couldn't have two, if you had two values of the same name in the console, it would override, the more recent one would override the older one. However, you cannot have two of the same name in the same, file to be compiled. It would break at compilation time.
Yeah.
So.
I guess I was just thinking like, I'm sort of used to like if I import something in Python,
Yep.
depending on how I import it, I can have like package name dot whatever function, and if two packages have the same function.
I think the more recent import one. Well, there's also a renaming function, so I could rename. If you don't want to bring everything into immediate scope, then you forget the dot underscore, and then all your access would be heirloom dot grandparent to child, heirloom dot child to grandparent, and so on. So you can leave as many layers of hierarchy on it as you want to, and sometimes you find yourself having to do that. Yeah.
Okay.
So, yeah, but there's also a rename. So I could do. There's a syntax for this. It would be heirloom arrow renamed heirloom or something like that. Yeah.
Okay.
So, cool. Yeah. What do you think? Hey.
I don't think this matters, but
Okay.
I'm not skilled enough to interpret it. So I see
fine.
that compared to the notes, where we have A, and then D is a subtype of A, right? In the actual imported code, it's flipped back.
Let's see. Okay.
And I don't know if that matters or not. Like, is this the reason why it's working? Probably not. I think this is saying D, and then A is a super type of D, which seems to be the same thing as...
Yeah, good catch. Let's see.
How do you just verbally articulate this?
Well, the whole question is kind of wrong, because it's meant to be a counterexample. It's meant to be, we have something intuitive, which is that heirloom transitions should only compile if the descendant is actually a descendant of the ancestor.
Right.
And then we find that's not
you
true.
would read this as saying heirloom transition, given an ancestor, and given that descendant is a subtype of the ancestor.
Yeah.
Right. So this is given a descendant, and given that ancestor is a super type of the descendant. That's going to be the same thing.
That's correct. Yeah. That's the explanation.
So my theory is that child is just extending parent, parent is extending grandparent. I see when I actually run it that it shows up, the types both show up as grandparent.
Yep.
And that's because child is...
But there's now you're right, but articulate that in terms of the Liskov substitution principle,
All right,
and you'll
sounds good.
yeah, and you'll be done. So thanks. How's it going, Harrison?
Good, I think it's going good.
Cool.
I'm poking around with code now.
Cool. Yeah. So
The terminology is interesting, like the concepts, like I'm familiar with, but I never really.
yeah, a lot of people, myself included, like we learn these things by trial and error, and then later we put like Liskov on it, So it's yeah. So so try and put your answer in terms of the Liskov substitution principle, and that's why the heirloom can pass from the child to the grandparent. So, yeah, thanks. Here's a kind of a hint and also kind of a requirement. When you think you've answered the question here, why does child to grandparent compile? Try and put it in terms of the Liskov substitution principle. So you can explain why the Liskov substitution principle is relevant here. How's it going?
Getting there. Just gotta figure it out.
You're going to figure out why it compiles? Okay.
Yeah.
Cool.
That's about it.
Cool.
So it's on me.
It's on you. Sounds like you figured it out. Can you put it in terms of the Liskov substitution principle? Well, you don't have to tell me. That's okay.
Well, I was just thinking it has to do with the fact that it's not proper subsets or when it inherits. Like, it inherits, like...
Well, so if I have A as a subtype of, that's what that last line is sub and supertype relationships are inclusive. A is a subtype of A. But more importantly, that enables it, but there's another reason here, which has to do with what can substitute for what else. And that's
everything that it inherits.
right, so any descendant can fill in for the parent.
Yeah.
Yeah, so that's why the heirloom can pass from the... Yeah. So it's just kind of counterintuitive. So, what do you think?
I think it's kind of mirrors the question I asked earlier about the parent types for that JSON file. It's so we're doing from child to grandparent, but they're both under great grandparent, right?
That's true, but it doesn't actually go that far back. So you were right to do this :T and look at the types. And so you see, in actuality, this instance of child to grandparent here, which isn't really supposed to work, but it does. I mean, it's not supposed to work intuitive, right off the bat. And then we find out because of how substitution works, it actually should work. So it is our understanding that is wrong, not the substitution. So what you're looking at here is the types of this and this, right? Oh, in reverse order, because this is supposed to be the ancestor and this is the child. Okay, so now read the first line of the Liskov substitution principle, and you'll find out why both of them are grandparents, even though it's quite clear right here that this is a child. Why does it come out as a grandparent? Yeah, so, thanks.
That's why it works. Because the only one that was being checked is this. And since that's child or parent, they're always a subtype of A. No, that's not right. This has the definition of it.
That doesn't have different. It depends on what you put in.
So what I'm saying is, when I look at A, is it referring to this parameter here?
Yes.
Okay. So then, if we put child here,
You don't have seconds, right?
and then this other one is going to be a grandparent, right? Grandparent is not a substitute. I don't know why it works.
And that is a valid question. Peter, did you want to explain or?
Yeah, in a little while. I'll keep walking around for a while. The whole point of this exercise is to break like the intuitive notion of substitution, and then it shows up all over the place. So it's.
What you're saying is like what people know what is it? I said that's
Okay.
well, same answer.
Okay, but this is the right way to read this.
Yes.
So whatever is this value here is what is being compared, or in terms of if it's needed names. Covariance and convariance?
That's a good. This problem actually does not involve that. This is just subtyping and supertyping.
Oh.
Yeah. The contravariance and covariance comes later. So part 2 and 4 should be flipped in order. It's my mistake. Yeah. Thanks.
So a hint to
How's it going?
So what it actually spins up here, but
So
basically injected grandparent.
That would be T. So S is a subtype of T, so T is a supertype.
Okay, so the code all compiles, and it's just a logic question. Figure out why, because it's supposed to break the intuitive notion. Okay, do you understand this syntax here?
yes.
Okay, so I'm making up 2 generic types here, A and D, and D is supposed to be a subtype of A. Okay, so this will compile so long as D is a subtype of A.
My child thing, when I put it in,
This part is intuitive. I put in a grandparent here and a child here, and it compiles. That much is intuitive. What's not so intuitive is why the reverse compiles, which is moving the heirloom from the child to the grandparent. That's not supposed to be allowed.
I understand the logic question.
Okay.
So, but we're not actually supposed to be doing anything then.
No, you just use the colon T, and you just look at the types and you figure out why. So the answer is the Liskov substitution principle. So you can articulate your answer to this, why this is allowed to compile in terms. Why is this important? Well, using type bounds is how we get certain type checking guarantees. Like I don't want this to compile unless the inputs meet something that I expect, right? So, but in order to do that, we have to have a good intuitive notion for what subtyping and supertyping actually gives us. So that's why we work with these types of examples. Does that kind of answer your question?
It does. So, I think I'm just kind of, if I do this.
Yeah. Oh, and then colon T, and then do grandparent to child or child to grandparent. So you're checking the type of an object that's in the scope.
Okay.
Yeah. So you have. Did you import from this package here? Look up. This is a file called heirloom. So in the Scala repository, do you have a clone of this this repository?
I do, yeah.
Okay, so open up, show me that. I'll help you find the file. Okay, go into let's see, the file is right there. So pull that up.
So, which means if you had specific traits in the child, probably.
You got to open up a text editor or something. Yeah. Great. Okay, so now you want to import this package and object. So you're going to do import com data science education tutorial lecture 1 dot Ireland dot underscore.
And I can do that from anywhere. Where do I?
Oh, if you've started up the console inside of SBT, you'll have access to this. So I don't know what you're doing here.
This is what I've done over here.
Good. Yeah. So then do import that package. Yeah.
That's what I was missing. Okay.
So, and then don't forget the dot heirloom dot underscore. Yeah. Here, just I'll just tell you. Yeah. Copy that. Great. Go back here. Dot heirloom. Yeah. Capital heirloom. The object is capitalized. Convention. Dot underscore.
I think I get the substitution.
Now what that does is it brings everything that's in that object into the immediate scope.
I see.
Yeah.
Okay. Yeah, some stuff I have to review, obviously.
Cool. Yeah. So yeah. Are you referring to the A and the D?
Yeah. Yeah.
So I know that there's two different definitions of the heirloom transition there, and they're actually equivalent. So
when I set the values inside here, I put the grandparent and child as case one.
Uh-huh.
And then when I actually look at type, it reverses it. It's now child.
Oh, yeah. There's a commented out version of what matches the tutorial, and there's an uncommented version that's opposite of what the tutorial says now. And that's why it's happening the way we just saw. So this is why. But the tutorial says this one. So I expected that one, but the reality is this one, which now explains why this happened.
Well, let's see. The order of the declaration of those two type parameters doesn't actually matter.
Well, in this case, it definitely does. So if you have them exactly the way the tutorial is, it would be exactly the way the tutorial states it. But it's not. It's opposite of the.
Oh, I get it. Because you're looking at the type parameters there.
Well,
here,
here it's saying, here I was looking at this. Right?
Okay.
So I'm looking at that as my reference, and I'm like, why is it saying child? Grandparent used to say grandparent, child.
Gotcha, yeah,
but
sorry.
The way it's written here, yes.
Okay, good catch. Yeah, sorry. Yeah, but
you see here? That's why.
I mean, the net effect is the same because, you know, the ancestor is either the super type or the descendant or vice versa.
The message is the same.
But yeah, I understand that's confusing. So thanks.
No, that makes sense. Here's a dumb question. This is how it's actually defined, not the way I was thinking.
Oh, okay, so this is how it's
Yes.
when one class extends another class, is child considered the super type of parent in this instance?
No, it's a subtype.
It is a subtype.
It is a
so
subtype.
when something extends another class, though, like you can add new things to the thing that's extending the thing that's being extended,
Let's
right?
see.
Like if I have
You
a child,
can.
the child has a method that is like burp, right?
Okay,
And
okay.
parents don't burp because parents are mature and old. So like my child has one extra thing. So is child a super type of parent because it has one extra thing?
No, it's still a subtype, and you could say that it's a superset of the functionality of parent.
functionality,
Okay,
still
because the child can burp, it can still do anything the parent can do plus
Yes,
burp.
right.
Yeah, so it can still be substituted for the parent. Now, if the parent could do something that the child could not do, then you're breaking the Liskov substitution principle.
Okay.
Because that would mean that you can't use the child as the parent.
Okay.
So like drink beer, and you can't put the child in that same function.
Right.
Because they're not able to do that. So yeah. So yeah, there's certain ways that I think in object-oriented programming you can break the principle, and then you have the repercussions. So, yeah. Yeah. Somebody caught a great mistake here on my part. Okay, in the code, let's go to heirloom.
That's how you learn.
Let's see. I have two versions of heirloom transition here, and they are effectively the same except for the way that the types are printed. This one here, I have an ancestor and a descendant. The descendant is a subtype of the ancestor. This one, I have a descendant and an ancestor, and the ancestor is a supertype of the descendant. So they're effectively the same, except when you look at the type of an instance of heirloom transition, those two type parameters in the brackets will be reversed. So that's confusing. One other thing, just Scala syntax here. You can declare as many of these type parameters, I also call them generics, as you want. However, the ones on the left cannot see the ones on the right. So you cannot do, I could not have a type bound on this one based on a type on this side. It has to move from left to right. That's why you always see these subtype and supertype relationships to the right. Also think of it this way. The type on the right side of any of these operators is actually concrete by this type. It's abstract over here, but here it's concrete because it's defined. I'm not making up D right here. I'm making it up over here. That's another way to think about it. I'm going to skip ahead to part 6 because I think type classes will probably be the highlight of this meetup. And a lot of bang for your buck with type classes. Okay, so here's the overview. We've been talking about object-oriented programming quite a bit, and we're trying to move away from that. Type classes are a concept out of Haskell that get used heavily in Scala. The basic idea is that you don't want to add functionality to your program by having to modify classes. In this example here, we have a class called model, and I want to add some functionality to it without actually changing the definition of model. In object-oriented programming, I would almost certainly have to do that. So we are going to see a way of adding some functionality to model without actually recompiling model. This is closely related to the adapter pattern. So I'm not saying that this is impossible in object-oriented programming. I'm just saying object-oriented programming, you tend to have inheritance. So if I had a hierarchy in object-oriented programming of organisms, and I wanted to, let's say it goes animal, mammal, cat. If I wanted to add some new functionality to mammal, I would have to go into that hierarchy and start altering the hierarchy. We're going to avoid that with type classes. We're still subject, though, to the Liskov substitution principle. So if I add functionality to a mammal with a type class, I should make sure that every descendant of mammal works with that type class. We want to add the capability of being plotted to many different objects and functions. Here's two examples of things that we want to be able to plot. We want to be able to plot a model, which has a domain and range that are generic. We don't know what they are yet. And we also want to be able to plot any function 1. Pretty ambitious. Any function one or model with the appropriate types. So we will be able to plot models that take in a double as the domain and output a double as the range. We will be able to plot function ones that take in a double as the input and the double as the range. We can't plot any function one or any model. I can't define this generically and plot any possible function one, because that doesn't really make sense. I wouldn't know how to plot any possible function one. So there are some bounds on it. But what you're going to see is we're not going to alter this trait in here in the Scala standard library, function one, to add its capability of being plotted. And we are not going to alter the class model. We are going to do it with a type class called plottable. And for pointers, I definitely look at the label maker example here. It's very similar. And there's lots of other type class examples in Scala. Let's look at one from Scala standard library. Let's see. Oh, better yet, let's look at cats, because we're going to be getting into cats soon. Monad is a type class, and I can have a monad for a list, for an option, for some sort of parallel type, like in the red book it would be called a par. I can have a monad for a future. Anything that can get set in here that obeys the monad laws, which we'll go over later. But all I want to hit on this right now is that monad is a type class. So I'm adding capabilities to list or future or option, any of those things, without actually altering the implementations of those three. It's all defined in this type class called monad. So that is the incentive to learn type classes, one of them. But we want to do something simpler, which is the plottable type class. Monad only has one type parameter. I had that f. That's not, having one type parameter is not a property of being a type class, though. You can have as many type parameters as you want. Just so happens that monad and monoid and their cousins only have one type parameter. So for anything that implements this type class, that's how you would say it. You'd say implements the type class. I could say list implements the type class monad. Anything that implements plottable is going to have a working version of this plot function. It's not completely implemented yet. What's cool about this is that you're going to implement def plot over these generic types. You have no idea what domain and range are yet. All you know is that you have a t, which is also generic. It could be a model or a function one or anything. And you have another method here, points. This part's a trick question. And you are going to be able to plot. You're going to be able to implement plot generically over that for any list of domain inputs. You're going to be able to produce a print statement that will print the outputs. And then you're going to make concrete, usable instances of this type class down here. So let me bring this back to monad real quick. I'll go over this really quickly. Just as a hint of what's to come. I'll put these side by side. Sorry? Say again, please. Yes, yes, yes. You're welcome. Thanks for asking. This is kind of a trick question, so I should just delete that part. This is an abstract method. You still have to define the signature, though. But I shouldn't have put that equals in there. Let's see. For anyone who's just catching up, this is in the file type class problem next to heirloom. Let me draw the similarity between monad and type class problem. Okay, so we have a type class monad. It's not so different from trait plottable. They're both traits in Scala. These two are of particular interest. These two are both abstract. That means that they are not concretely defined in this trait itself. The rest of them down here under the concrete bar are defined in terms of the abstract methods. So basically with a monad, you implement these two methods, and so long as your implementations satisfy the monad laws, you get all this behavior down here. Let me skip to a couple of the most famous ones. You have flatten. You have replicate. You have sequence and traverse. Oh, given an instance of traverse here. So those two are a bad example. But you have map. It's alphabetical. Here's map. It's a famous one. Lift. All I'm trying to get across here is that for two abstract methods, you get all this other behavior. How is this relevant to plottable? Well, in plottable, we have one abstract method, and this is going to be defined in terms of that one, with these three generic types here. So plottable itself is not a concrete type. You can't do anything with just a plottable. You have to fill in the abstract types, and then you get a concrete instance of plottable, like plot double-double function or plot double-double model. And I will help you with that. So let's look at the description for the first task. Oh yeah, it wasn't intended to be a trick question. The reason that you saw 3 question marks here is that you cannot compile. Almost all the time I try and give unimplemented but compilable Scala code to you. So it's something that will produce a runtime error if you try and run it, but other than that it will compile. You can do that with these 3 question marks. However, you cannot define a definition in Scala abstractly that does not have some type of return type. Figuring out what the input type and the output type of this def is the challenge. And without putting the equals question, it would not compile. So it wasn't to trick you into thinking that this is a concrete method. It was because I had to keep points compilable for this part of the exercise. But on your own, you should delete that. Plot is just a function that prints the output to the console. So you're going to get an input sequence and an output sequence. The hardest part of this exercise is implementing the abstract part, which is the type class plottable, before you have a concrete instance of it down here to actually test against. So that is a tricky part of this. You don't get to immediately test what you do for task 6A. How's it going?
I was actually working through the advanced cats, but.
Oh, okay. Cool. That's fine. Let's go. Am I doing decently? I haven't started yelling. Hey. Cool. No worries. Let's see. Okay, so first of all, delete that equals question, because that has to go away. And also delete the, yeah. So you're going to figure out what the signature of def point should be.
Okay. For this, right?
Yep.
T is an option that can take domain to range. T is like, you use T to transfer to translate the domain.
How's it going? What do you guys think?
I'm still getting my bearings here.
That's fine.
I left at a critical point.
It's okay. How are you, Snow?
Combinations of a programmer.
Oh, okay. Well, maybe I can help you out. Hey, Harry. One sec. Oh, good. Yeah, good. That's the type classes example. Very similar to this one. So what he's doing here, he wants the capability of printing labels. He wants to define that on a type class. For all these other types, there's all sorts of things that you can print a label for, of all sorts of different, areas, right? That might not have anything in common. So it's not a good way to use inheritance, because I don't want everything that can possibly print a label to have a common parent. So that's why it's a better idea to use a type class. One reason.
Oh, I have to implement points before I can compile.
Are you implementing points in the type class plottable?
No, I have the abstract, but now I can't compile because plot double needs it.
Exactly. Yeah. So points becomes it becomes concrete in plot double. Yeah. Exactly. It has to become concrete sooner or later.
Yeah.
Yeah.
I need to make it.
Cool. How's it going?
I have no idea what I'm supposed to do.
Okay, okay, that's okay. Let's look at. Okay, so this has to go away. This is just an artifact. I hate to.
What's the goal here exactly?
Okay, the goal is to move beyond object-oriented programming, because ordinarily, let's look at the label maker example. Oops. Okay, so what he wants to do here is capture like the capability of printing a label.
Okay.
And there's all sorts of things that can go to a label, right? You know, any object, it can have some sort of label printed for it. However, if I were to use a traditional object-oriented technique on this, I would end up having everything that can possibly print a label inherit from some common parent, which I don't really want.
Right.
Because they have nothing else in common except that they can print a label.
Right.
So traditional inheritance has failed us there. A type class is a more elegant way of capturing this. So they can have something in common, but they don't have to have a common parent. They don't have to have any sort of subtype relationship.
So is the goal to define a method that's accessible to all sorts of things, even though they're not part of the same
Hierarchy. Yeah, exactly. Exactly. Yeah, and that is by you have an abstract type class here, label maker, and you're going to create instances of this. So I'm going to have label maker for addresses, label maker for food, label maker for all these different things. That yeah.
So in that case, what will be the common thing? Like the method itself will be. So like in that standard like object-oriented programming, you might define basically a method that's essentially empty, and maybe for each of the classes you can have like a sort of sub-definition or an override for that, right? And I guess in this case, is it the case that you want different functionality for each of the things that use label, or is it going to essentially be exactly the same?
Okay, that's a great question, and this is one of the shortcomings in this example is that it only has one method, and that's why I had plottable. So what's shared by all of them, what's entirely in common is that def plot method, because what's in common is that everything that implements plottable will print to the console. So that is completely in common. What's different between them is their implementation of points, def points. That is very different between different things. For instance, it's very different between a plottable of a model and a plottable of a function one and a plottable of any other type that has a domain and a range.
Okay.
Yeah, so does that answer your question?
Yeah.
There's something in common, but there's also something that's different.
Right, so you basically have like a method, it's got like a sort of base thing that everything needs,
Yep.
Which is the plotting the points to the console, I guess.
Yep, yep.
And then there's how points are defined.
Yep.
Might be very different.
Exactly. Let me explain this to everybody, because thank you. That helped me. So let me hit on a couple of high points here. It doesn't make sense to have a type class if you do not have an abstract type. So let me talk about inheritance a little bit. Let's look at the label maker example, which is linked right here. So he wants to define a label maker like a printer for all sorts of different objects. And anything can have a label printed for it. Maybe the label comes out a little bit different. I can print a label for addresses. I can print a label for food. I can print a label for anything. It's a very general concept. However, I don't want to implement this common label printing functionality with inheritance, because that would mean that anything that can print a label has to have some common ancestor. So I don't want everything that can conceivably be printed to descend from a label maker class, because maybe I don't want that subtype relationship. Type classes are the solution here. And what he does is he puts common functionality in the label maker, and then anything that implements this type class, like I said, list implements the monad, option implements the monad type class. Address implements the label maker type class. Then address gains the capability of label maker. What the shortcoming of this upper half of the example is, let's see if there's a better version down here. Print label. Here's the difference between what's at the top of that page and this version. Is the common pattern with a type class is that you have something in common, which is this, between anything that implements plottable and something that's not in common. Anything that implements plottable will have its own unique implementation of this abstract method definition points, but they will all have in common the same code here for def plot, unless you were to override def plot for some reason. So the pattern with type classes is it doesn't make any sense if you don't have an abstract method up here. You wouldn't need a type class for that then. It also wouldn't make any sense if you don't have some shared concrete functionality. So what I'm factoring out here is the common behavior of putting samples into a function, pulling out the samples, the outputs of the function, and printing it to the console. Of course, a real use case of a type class is going to factor out something more useful than a print statement. And I'll back that up with a monad Every one of these implementations, every one of these methods below in concrete value members is like a different puzzle to implement. You don't want to be implementing these things over and over again. So it's the same concept as def plot here, in that it's shared